So you turn your computer on and then suddenly you hear a sound like this. And if you don't know what that is, it could cost you a lot of money. But if you know your computer basics, it'll take you about 15 seconds to solve your own problem. So in today's video, I'm going to explain to you the 7 absolute things every computer has to have in order to function. And you don't have to be a computer expert, and you don't have to understand all the bells and whistles and how everything works in the background. I'm just going to cover the basics for you so that you can do some basic troubleshooting if and when you ever have a computer problem. Hey guys, I'm Scott Merrill. I've been in the IT industry for almost 35 years now, and one of the things I do on this channel is offer you Windows tips and tricks, troubleshooting, and how-tos on all kinds of issues with Windows and hardware. One of the things I also do is offer free recommendations if you're looking to buy hardware and you don't know exactly what you need. So there's a link in the description. If you click on that and fill out the form, send me that information and let me help guide you to make the right purchase. 100% free. I'd be happy to do it. Now let me kind of tell you how this all started, because I'm a computer guy. You guys know that. And when it comes to cars, I don't know anything. What I do know is that I have a friend who knows way more about cars than I ever will. And my car started making a funny noise the other day, and so naturally, because I didn't know what that might be, I freaked out and I took it to him and I said, it's making this weird noise and fix it. You know, that's what you do. Fix it. Okay, put it in drive and let's see what it does. So I drove and made it about 10 feet and he screamed and said, stop. Of course, I stopped the car and he walks over around the side, looks underneath, pulls a stick out from underneath my engine. Apparently, I ran over a stick that got caught up in my wheelbase, and just like that, the problem went away. And some of you may be feeling that same exact way, where you use your computer and when everything's working, you don't really care what happens under the hood, very much like I don't care about my car as long as it runs and drives. But he looked right at me and he goes, you know, you should at least learn the basics so that you can do some basic troubleshooting, or at least be able to tell me where the problem's coming from. And so that kind of inspired me to make this video today. So again, we're gonna just go through the very basics, the 7 things that every computer, laptop, desktop, all-in-one, whatever, all of these things have to have in order to function. And at least that way, when you have a problem in the future, you'll kind of know where to start. So one of the necessities for every computer to run is the brains of the unit. And that is what's known as the CPU, or Central Processing Unit. I have one here. They're little tiny guys, not very big at all, but this is generally going to be the most expensive part of pretty much every computer, because everything you do runs through this processor. So every time you click on something, every time you try to open something, every time your computer powers up, your CPU goes to work and starts processing instructions. Think of everything you do as an instruction. You're telling your CPU, go do this, whether it's open a document, open your web browser, power the computer on, all of that stuff. Everything has to run through the CPU. That's one of the things every computer has to have. You don't necessarily have to know how it works, just know that this is the workhorse of pretty much every computer. If you look here inside this desktop, you see this fan right here. Right underneath that is your CPU. It actually goes in, it's got pins on the bottom and it goes in a certain way. There's a whole bunch of different varieties of CPUs. We don't need to get into all that. You know, some are more powerful than others. But what you need to know is that that thing underneath here is basically the muscle. And that brings us to the second thing that every computer needs, is CPU cooling. Now in desktops, generally it's going to be a fan, just like this one, that just sits and mounts on top of that CPU. Because that CPU will get really, really hot. I mean, hundreds and hundreds and hundreds of degrees. And so the fan pulls that heat off that CPU, and then that heat that's trapped inside your computer gets blown out through your exhaust fans. So that's basically how that works. The CPU is required to perform instructions. The CPU fan is only there to keep the CPU cool. And if your CPU overheats, your machine can sometimes just power off randomly, or it'll turn on for a few seconds and then shut down. That would be one of the first things that I would check to make sure that that cooling fan is not gunked up and has a bunch of dog hair in it that's sucked in or whatever. If that fan isn't spinning properly, the CPU isn't going to cool properly. If the CPU can't cool properly, it will initiate what's known as a thermal shutdown. And that basically sends instructions to your main board to power off so that it doesn't damage your system. Now, that being said, the third thing that's required on every computer is what I just said, the main board, also known as a motherboard. This is the big green thing right here. The motherboard itself really doesn't do a whole lot. It's basically a conduit so that everything in your computer can communicate with each other. including your drives and your memory and all that other stuff. Everything runs through the motherboard through a series of circuits that are imprinted on the board. If you look real close, you'll see a bunch of lines and stuff going from connector to connector. That's basically how instructions are sent from one device to the other. Now, the next thing that every computer needs is memory. That's these little guys right here. And this is getting heavy, so I'm going to set this down for a second. So this is what's known as RAM. Now, you may have also heard of it as a memory module, a memory stick. Doesn't really matter what you call it. It is what it is. It's memory. And the RAM actually stands for random access memory. Now, what does that mean? When you send an instruction to your CPU that we just talked about, it executes that instruction. And how it does that is it then sends that information through your memory, right here, through a series of zeros and ones to have your physical hard drive, which we'll get to in a second, have that drive go do something. Boot Windows, open a file, open a picture, open a document. Basically, RAM is storage. You've heard the term hard drive. That is physical storage. This is actual physical storage too. But the difference between memory and a hard drive is that this is what's known as volatile. And if you've ever been working on a document and your computer powers off and you bring it back up and suddenly that document is gone, that's why. Because pretty much everything you're doing is working through memory, and until you actually save it to your hard drive, your storage medium in your computer, it's not saved. That is non-volatile. You write a file to your drive and there it is. But while you're working on it, this is so much faster than a typical storage drive. And so that's why this is the conduit between your CPU and your physical hard drive. And the more of this you have, generally the faster your computer is going to run, because this can only hold so much data at any one time. So the more memory you have, the more your CPU has to work with. It can push more data out because you have more memory. These, when they go bad, can often cause blue screens. If you've ever had a blue screen of death and you don't know why, I've fixed so many blue screen problems by just pulling one or more memory sticks out of a computer, because when it fails, the CPU can't write information to it, and therefore it just kind of throws up on itself. And sometimes your computer won't even boot. Now, there's different ways to test memory. We won't get into that in this video. But if you have a consistent blue screen of death problem, you can look at the error code in that blue screen. And if it says anything about memory or memory management, I would start pulling these sticks straight out of your computer one at a time until the problem goes away. And then usually, there you found your problem. Get another memory stick, life is good again. And another thing, if you need to replace memory, it's super easy to do. It literally just pops in and snaps in place. But you'll notice that there's a notch right here. That notch aligns just the right way in your computer. It's kind of idiot proof. You can't really put it in wrong. It just won't fit. You have to line that notch up and then snap it down. I'm gonna try to do that one-handed. Let's see if I can show you. If you appreciate the fact that I'm popping memory stick in with my left hand while holding a computer up in my right hand, make sure you hit like in this video. If you notice here, see these little clips? I always called them banana clips. I don't know what the actual term is right here. These little things, they just snap like that. There's little grooves right here where this piece slides right into. So you can literally just slide it right into place and with one hand, snap it there, and these clips will pop down and hold that memory in place. And that's all you have to do to replace a memory stick. Okay, so far we've covered the CPU fan, the motherboard, and memory. The next thing that every computer needs is some kind of storage medium. Now, if you have a desktop, you're probably going to have a drive about this size. Laptops are going to generally have a drive about this size. This is what's known as a 3.5 inch drive because it's 3.5 inches wide. This is known as a 2.5 inch drive. Typically, these are called desktop drives and laptop drives. Now, there's also other kinds of drives that if you look inside your computer, you may not see them. They look more like this, ironically, like a memory stick, but this is actually what's known as an M.2 or NVMe drive. Again, don't worry about the technicals of it. If you don't see a drive that looks like this or the smaller version, it's probably because of this. But the question is, what do these things do? So as I explained before, when you click on something and your CPU says, okay, I'll go do that, it sends that instruction through your memory, through the rest of your main board, to your hard drive. Now, generally, this is where you're going to have your Windows or other operating system installed. This is where you're going to have all your documents, your pictures, anything that you have created and stored on here. And this communicates with your memory back to your CPU and so on and so forth. And it just does that millions of times a second. We've had conversations before about making sure that you back up your data. This is what I wanted to explain to you. What you store on here is what's known as non-volatile. What non-volatile means is that once it's written to here, it stays here. You can restart your computer, bring it back up, and all your stuff is still on it. Nothing's happened. Whereas with memory, once you restart the computer, it gets wiped clean. I've had a bunch of computers before that were completely dead, and the client freaks out and says, "Oh my God, did I lose everything?" I'm like, no, you didn't. Because as long as the hard drive is okay, which most of the time it is, your data is still stored on here. I can pull this drive out of a computer, plug it into an external drive reader like this one back here or any other one, and copy the data right off of it. And then if we need to replace the computer, we got all your stuff. So this basically, just think of it as storage, whether it's a 3.5-inch drive, a 2.5-inch laptop drive, whether it's an M.2 drive or anything like that. It doesn't really matter. What you need to understand is that this is just storage, okay? Hopefully that makes sense to you. Now, depending on what kind of computer you have, your hard drive may be plugged in somewhere down in here or wherever. In this one, because it has this little clamshell thing, the hard drive is actually right here. It's connected to your main board through one cable, which is what's known as the data cable, okay? That allows your hard drive to communicate with your motherboard. And again, all the instructions that your CPU, memory, and all that, it's all going through that data cable into a data port on your hard drive. Just so you know, the tiny connection here is where the data connector goes. And then this one right here is where the power goes. And again, you have to have power or the device won't work. So again, in this example, we've got the blue data cable, and the color doesn't really matter. We got the blue data cable that connects to what's known as SATA ports on your motherboard. And you don't have to worry about what they look like, just know that they've got to connect. The other cable that comes in here is going to be a bigger cable, and it's going to look like that. That one goes into that wider port on your storage drive. Now, if you have an M.2, it's a little different because it connects generally directly to your motherboard. It doesn't have those. But if you have a typical standard mechanical drive or an SSD drive or whatever, it's going to have those ports on it. Those are the two connectors you need. That cable comes from this thing right here, which is known as your power supply, or PSU. If you turn it around, it's this thing right here where you plug it right into the wall. When you hit your power button, it sends a signal to your motherboard through a bunch of circuits and switches to turn the computer on. And then at that point, your CPU and memory and everything else do what they do. Now, the PSU, or power supply, is pretty important because depending on what components you have inside the computer, you may need a more powerful power supply. Most of the time with basic factory stuff that you get off the shelf, it's going to have a smaller generic power supply, usually 350, 400 watts. If you're a gamer or you have a bunch of add-on cards and stuff like that, you're going to need more power. But for the computer that's just right off the shelf, something like this is absolutely fine. And as an added bonus, if you have a problem with your power supply right here, generally it's just 4 screws and this thing comes right out. Then all you have to do is just buy another one, swap out those same cables exactly where the old one went, plug it in, turn it on. That's an easy way to fix a power issue if you hit your power button and nothing happens. Now, you can do other things like test for voltage or things like that, but most of the time when you hit your power button and nothing happens, it's because the power supply has blown out or you've overloaded it. You can get most standard desktop power supplies for about $29 to $30 on Amazon. I do it all the time for people who just have basic computer needs and don't need a lot of power. A little 350, 400 watt power supply is going to be more than enough. Now, the other thing that every computer has, whether it's a laptop or a desktop, is what's known as a GPU. And that stands for Graphics Processing Unit. Just about every computer is going to have a built-in video card. You'll know this because you'll see HDMI connector, maybe a DisplayPort connector, or a VGA or DVI, the blue or white connectors. But just about every computer has what they call onboard graphics. Basically, onboard graphics just means it's a chip about that big that sits on your motherboard or main board. Now, you don't have to have a fancy graphics card, especially if you're just using it for daily usage. You just plug your monitor into here. If you have a desktop, you definitely need a monitor. If you have a laptop, your screen is your monitor. And if you have an all-in-one, your screen is your monitor. So the asterisk to this is that if you have a desktop, the 8th thing you technically need is a monitor, because you have to be able to see what's going on with your computer. If you have a laptop or an all-in-one, it's built in. So the GPU, again, is generally an onboard chip that controls video output. In other words, what goes out to that screen that you're looking at on your desktop. Now, you can get an add-on card. Let me show you what those look like. Okay, so this is what's known as an external graphics card or an external GPU or video card, basically. It's got the same HDMI connectors and what have you that your main board has on the back that I just showed you. But basically the reason you would want one of these is because it's much more powerful. Anything that you do on your computer with the onboard video is handled by that little chip and your CPU. But when you plug in one of these, this basically has its own processor and dedicated memory in it. So it takes the load off of that CPU and puts it on the GPU. Now, why would you want one of these? Well, a lot of people who are gamers definitely use these because that gives them extra processing power, gives them higher frame rates and all the fancy stuff that gamers need, gives them more juice to play their games. Or if you do graphic design or any kind of editing, stuff like that, this can take the load off of your CPU and make your computer more powerful. And we won't get into the different types of connectors, just know that there are them. But you'll see connector types like this. And what this does is it actually slides down into one of those, what they call expansion ports. I'll show you what that is. Again, if you appreciate the fact that I'm doing this one-handed, make sure you hit like. Definitely won't have to go to the gym this week. These right here, you can see the little black, the blue, the cream colored, and the other black one. These are what's known as expansion ports. Now, in my previous example, this card would go and slide down into one of those ports. Then those connectors would be sticking right here. You plug in your monitor, and now your GPU is handling that heavy workload, and your computer's CPU doesn't have to. Now, the last item on the list is technically not an absolute requirement because you technically don't really need it. But that box that I showed you, that's what's known as your tower or your computer enclosure. Now, there's 100 different names depending on who you ask, but basically what that means is that everything inside your computer bolts down to that frame, and then everything connects into it, and then you turn your computer on and everything just works. So that's a desktop enclosure, and they do make them in different sizes. The super tiny ones are called minis. They're about this big. Then you have small form factors, medium form factors, which is basically what I showed you, and that's commonly called a mid tower. Then you have the big ones, which are full-size towers, meaning that gives you the most room to plug in cards and get in there and not have to break your fingers trying to replace stuff. It gives you a lot of flexibility. The size of the enclosure doesn't matter. You could have a motherboard this big inside of a huge tower, or you could have a full-size motherboard with all that parts and stuff inside of a mid-size computer, just like that one. So don't worry so much about which tower is which, and they all do the same thing. They just allow you to put everything in one place. Now, laptops have all the same components, but everything is miniaturized and it's all pretty much in one place, and that's on the main circuit board. Your power is generally going to come in through a little hole like this. Your adapter plugs in and your computer works. The power supply is actually built onto the main motherboard of the laptop. You also have a built-in graphics card, which you'll see because you have external ports here. You could connect this to an external monitor and it would work fine. But the problem with the laptop is you can't go get one of those big fancy gaming cards to connect to it because it's a laptop. It's designed to be tiny and thin and mobile. But it does have that built-in GPU on the main board. And just like with the desktop, it does have its own CPU. It does have cooling system that's built into the board. And it also has plenty of fans to push all that air out right here through these exhaust vents. So basically everything's the same with a laptop or an all-in-one as it is with a desktop. It's just much, much smaller. It's for reasons like this that I would normally recommend that if you need a desktop versus specifically needing a laptop, get the desktop. And the main reason for that is because if something breaks with one of these, it's going to cost you a lot more to replace that part than it would if you had a desktop. For example, the power supply in a desktop, if it goes out, $40, 4 screws, and you're done. If the power goes out in this, most of the time it's that little jack that's inside of here. It's about that big and about a $5 part, but it's going to cost you $150 to have somebody take the laptop apart to replace it. And that's if it's just that. So there's so many more things that could go wrong with a laptop than a desktop. But the most important thing is that you familiarize yourself with all the different components and realize that you don't have to be scared of that computer. You don't have to be scared to open it up. Once you kind of understand what everything does, at least you'll have a pretty good idea if something goes wrong, where to start looking. And usually what I tell people is start unplugging stuff until the problem goes away. That's one of the best troubleshooting steps ever. Whether it's a blue screen or a funny noise or whatever, a lot of times disconnecting one device and all of a sudden everything works. I've actually had a DVD player that was hooked up to the computer that it was a faulty device. And when that DVD was connected, the computer wouldn't boot. I literally pulled the power cable out of that thing, computer fired right up. Replaced the DVD drive, everything's good. Okay, so in case you were wondering what that noise was, sometimes these cables come loose and start roaming around, and normally it's no big deal. But you see this fan right here, this cable had come loose and was sitting on top of this fan as the blades were trying to spin. That's that noise you heard. If you had opened this case and saw that this was laying there and you literally pulled it off the fan and the noise went away, guess what? You just saved yourself a service call. So I hope this video enlightened you a little bit. I hope you enjoyed it. I know it's not my typical video, but I figured it might help some of you novice users out there understand what's going on under the hood, and if nothing else, maybe help you troubleshoot your own computer. I'm not sure what YouTube thinks may be your next choice for video, but I'm pretty sure it'll pop up right here. Thanks so much for watching. See you guys in the next one.